Hi everyone, welcome to today's deep dive into how the internet actually works. Whether you're streaming a show, sending an email, or scrolling TikTok, all that data relies on some fascinating systems. By the end of this video, you'll understand the secret highways of the internet, circuit switching, packet switching, and the role of routers and protocols. So let's get started. First up, circuit switching. Imagine you're making a phone call in the 1980s. When you dial a number, the phone company literally reserves a copper wire between you and the person you're calling. That wire stays yours even if you're silent. It's like booking an entire train just for yourself. It sounds quite luxurious, right? But here's the problem. It's super inefficient. If billions of people tried this today, we'd need a wire for every single device. That's why the internet uses something smarter, packet switching, which we'll explore next. So here's a quick note. Circuit switching isn't dead. Some older systems, like certain emergency networks, still use it. But for the modern internet, it's like using a horse-drawn carriage on a highway or a motorway. Okay, let's talk packet switching. Imagine you're mailing a 1,000-page book to a friend. Instead of sending it in one giant envelope, you tear out each page and mail them separately. Some pages go by plane, others by truck, whatever's fastest. That's exactly how internet sends data. A 10 gigabyte video is split into millions of tiny packets, each taking the quickest route. But here's the catch. Distance does matter. A packet from London to Sydney might take 40 milliseconds, like driving cross-country with pit stops. Meanwhile, a packet to Paris might zip there in 5 milliseconds. This delay is called latency, and it's why online gamers hate slow connections. We split data into packets. It's simple. Is for efficiency and reliability. If one route crashes, the rest reroute, so there's no traffic jams. Now, meet the unsung heroes of the internet, routers. These are like GPS devices for data. Every time a packet arrives at a router, it checks its routing table, a dynamic map of the internet, to decide the next stop. Each jump between routers is called a hop. For example, a packet from London to Sydney might hop through New York, Singapore, and finally to Sydney. If there's a traffic jam in Singapore, the router reroutes it through Los Angeles. Routers are like postal workers with super smart maps, working 24/7 to keep your data moving. Here's a fun fact. Your home Wi-Fi router does this too, just on a smaller scale. So next time it crashes during a Zoom call, maybe give it a bit of a pep talk. Let's dissect a data packet. Think of it like a suitcase. Number one, the header, the luggage tag. It has the senders and receivers' IP addresses, a sequence number like suitcase 3 of 10, and TTL or time to live, a counter that decrements with each hop. If TTL hits 0, the packet dies to prevent infinite loops. Number 2, payload, the close inside. That's your data. It's like a snippet of a video. Number 3, the trailer, a lock and checklist. It uses checksums to ensure nothing's damaged. If the numbers don't match, the receiver says, hey, resend that. But why keep packets small? Imagine mailing a suitcase versus a shipping container. Small suitcases are easier to reroute if a road closes. Now, without rules, the internet would be chaos. Enter protocols, the traffic lights of data. For example, HTTP lets your browser fetch websites. TCP ensures packets arrive in order, like a meticulous librarian. UDP is faster but careless, perfect for live streams where a dropped frame won't ruin the show. Standards matter. Imagine if phones used a secret language Androids couldn't understand. TCP/IP is a universal translator, ensuring every device speaks the same language. Have you ever connected to a Wi-Fi or connected Wi-Fi to fiber optic cables? That's a gateway, a protocol translator. Think of it as a bilingual tour guide for your data. Let's unpack the TCP/IP stack. A 4-layer cake powering every internet message. First up is the application layer, the top chef. This is your browser or email app. It uses protocols like HTTP or SMTP to say, I want this web page. Second is the transport layer, the sous chef. TCP chops data into packets and numbers them. If one goes missing, it will yell resend packet number 5. Third up is the internet layer, the delivery driver. IP slaps on addresses like 192.168.1.1 and routes packets. The fourth is the link layer, the delivery van. It uses MAC addresses such as 4B:24:A2:73:0E:0E:F1 to physically connect devices. Now here's an analogy. Sending data is like ordering a pizza. You call, which is the application layer. They cut it into slices by the transport layer. They add your address, which is the internet layer, and a bike delivers it. That's your link layer. Have you ever uploaded homework to a school server? That's FTP, or File Transfer Protocol. It uses 2 doors, port 21 for commands, such as delete this file, and port 20 for the actual data. Anonymous FTP is like a public library. Anyone can download files without a password. But beware, FTP isn't encrypted. For sensitive files, use SFTP, the secure version with a lockbox. Let's demystify emails. When you hit send, SMTP whisks your email to the recipient's server, like dropping a letter in a mailbox. But retrieving emails, that's where POP3 and IMAP differ. POP3 downloads emails to one device and deletes them from the server. It's great for saving space, but bad if you check email on multiple devices. IMAP syncs emails across all devices. Delete one on your phone and it vanishes everywhere. So here's a real-world example. Using POP3 on 2 devices, like having 2 chefs cooking the same recipe but not talking. IMAP, they're in sync, like a perfectly choreographed dance. Time for a quick quiz. Pause the video if needed and have a go at answering or identifying the blanks. Well, in fact, I have already provided the answers there. So data is split into packets for transmission. The TTL limits how many hops a packet can take. Routers use routing tables to determine the best path. IMAP versus POP3. Which keeps emails on the server? The answer is IMAP. And FTP uses port 20 and 21. So here's a final tip. Relate these concepts to real life. Packets are like postcards. Routers are GPS devices. And protocols are rule books. Thanks for watching, and go ace your exam or test or wherever this may come up. Hit like if this helped, subscribe for more A-level content, and drop questions below. I'll see you next time. Bye for now.